This video describes the 3D modeling of vertical bearing support as described in module number 11. It is as per the procedures in the handout developed by Mohammed Younas and John O'Brien. The orthographic views, front, top and the right, for the vertical bearing support are provided to us. In addition to it, we have the isometric view and an auxiliary view describing the details on the slot body. The following steps may be used in modeling the vertical bearing support. We have the base as the first feature. We have the boss for the slot body, and then the slot body on top of it to be added at an inclination, a slot cut through, and a slot coming at the bottom of the boss, base boss, and then you have other bosses for the holes. Finally, drilling all the holes, counterbore holes, simple holes and threaded holes onto the part and adding fillets at the sharp edges. We make use of Solidworks 2019 to model the vertical bearing support. Select a new file from the standard menu, part file as the document. We have the units as millimeters. Select the top plane from the feature manager, design tree. Turn on the sketching. Select a rectangle as the sketch entity from the sketch toolbar. Corner rectangle as the rectangle type. Starting with the origin, drop the second click on the diagonally opposite end. We have got the dimensions for this. Before we assign the dimensions, let's add the fillets that come at these sharp corners. So your sketch toolbar, we have sketch fillet. Pick up the corner on the top. Also add the other three corners to the same sketch fillet feature. A radius of 32. Then we assign the dimensions to fully define the sketch. Smart dimension under sketch toolbar. Pick up the center of the fillet on the top left and the top right corner. We have the distance between these two as 216 and center to center distance along the vertical right as 72. Let's zoom to fit the whole sketch in the screen. This is the fully defined sketch now. Extruded by using features toolbar, extruded boss base to a height of 32 millimeter and accept this. That forms the base feature for the vertical bearing support. The next is to add the slot body, the boss for the slot body, which projects out from the surface over here, and the shape would be as described from the right side view. So we create a new plane in the center of this base by clicking on the right face of the base, going over features toolbar, reference geometry and plane, and select the plane under the reference geometry. We have got the first reference here. You have in the property manager for the new plane, you have three references: first reference, second reference and the third one. We select the first one as face 1. It's the right face on the base, and then flip the side, check on the box, flip offset to move the plane into the part and assign a distance here. Activate the offset distance. This is already highlighted. Just type in here distance of 140 millimeter, move it into the middle of the base. Accept this and you have a new plane added in the design tree as plane 1. Use this plane as a sketching plane turn on the sketching, click on normal tool in the view orientation, and then add a contour by using line as the sketching entity. You can go into the top of the base to get a inference line, and from there on you can add another horizontal line and make a closed contour. We have the dimensions from this end to the far end of the base as 185. Get the sketch in the form as before by moving the underdefined sketches, smart dimension, the angle between these two lines 60°, and the height as 32 or 35. We have the base here for 32. This is slightly higher than that, and as we will have another boss coming in at an angle, would like to fill up the cavity or the gap that would come from the bottom of that particular boss. So that's the reason we have this as 60° and a slightly greater height of 35 millimeter. View orientation, isometric view, and then assign the boss. You have extruded boss base. We make it as a mid plane to have the boss on either side of the sketch, 130 millimeter as the thickness. We then add another plane, reference plane, to add the slot body. We go over features toolbar, reference geometry, plane, the first reference, select the top edge here on the slot body base and make it coincident to the new plane. Select the second surface, in the second reference select the face in the front here and assign an angle between these two by activating the angle here. Press on the icon for the angle and then given a value of 30°. Okay. You get the plane 2 as the new plane in the feature manager design tree. Select this plane, turn on the sketching mode and then go normal to it. Okay, we can use it in this manner. Use rectangle and then a corner rectangle. We use the top end of the edge here and then make a rectangle, align it with the ends on the from the previous feature. Select these 2 points, make them coincident to have the same width for the new rectangle and height here in the true size as 97. View orientation, normal isometric view. Features, extruded boss base, and add a distance of 32 and reverse the direction. Let's look at it from the right side. This is how it would look like. Filling up, we have an extra portion here of the height going up to 35 millimeter and the angle 60° to make up the space that would come up due to extrusion at this normal extrusion of this slot body, normal to the sketch that has been made on the new plane. So that's the details which were described in the previous feature. Accept this to add the slot body. Add the fillet to remove the sharp edges here using features toolbar. You have fillet feature. Pick up the sharp edges, use constant size, and then select the edge on the right, a similar one on the left. Assign it a radius of 20 millimeter. Accept this. You may hide the planes which have already been used. Plane 1, right click on that and click on hide in the quick toolbar. Plane 2, you may hide the second plane as well. We then cut a slot over here on the surface. The true shape of the slot is shown on the surface. Select the face, make that a sketch plane, going normal to it under view orientation. Sketch the profile using a line. Let's add a center line to fully define the sketch. Defining the center line by giving a symmetry relation with the existing boundaries on the either side of the block. We have got the dimensions for the slot as 26 for the smallest step inside, and then 52 for the overall width of the slot. A depth of 10, and then the other one inside there with 3 millimeter. Assign relations to the other lines. You have the line on the other end and the line here as collinear. We have got this vertical line with the center line as symmetry relation to have it equally distributed on either side of the line for the width of 26. The same goes with the width 52. You have the two ends of that dimension 52 and the center line being selected using the control. You can press the control key on the keyboard and make multiple selections, or you may also go to add relations under display, delete relations, add relations, and then assign these sketch entities under the property manager. You have a symmetric relation between these three lines. This fully defines the sketch. Going over isometric view under view orientation, and then in the features toolbar, extruded cut. The cut goes through the entire part, so we can make this as through all as the end condition. We then have a slot coming at the bottom of the face. Select the back face, make that a sketching plane, going normal to this, and then use line under sketch toolbar to add an inclined line, horizontal one, and another similar inclined line. Make it a closed contour by closing it from the bottom, and adding a center line to define the sketch by assigning a symmetry relation. We first initially make the center line symmetric to define it, then assign dimensions 45° between the horizontal and the inclined line. We have the distance as 152 between the far ends here. and a height of 3 millimeter. Add a symmetry relation between the two inclined lines. To fully define the sketch, and then use features cut extruded cut to remove it all through. We then add the boss on top of the surface here. Select the top surface, make that a sketch plane, go normal to the surface, and under sketch toolbar select straight slot. Drop the two centers for the straight slot, assign a radius. Use smart dimension to assign the dimension for the straight slot. We have got the radius over here as 22, and the center position is concentric with the outer curve. So pick up the two arcs and then make it concentric. The same on the other end. We have got another one on the other side here, which is a mirror image. So we can use a center line, make it symmetric, and use this center line to mirror the sketch on the other side. You have sketch toolbar, mirror entities, and then the entities to mirror is the straight slot. So you may make a multiple selection by making a left click on the screen, dragging and making a window around the sketch. Select all what you have in there, slot 1, and then copy, check the box, copy, mirror about, select the axis line or the center line to mirror about it. We get a preview here, looks fine, say OK. Extrude both of these two contours using features, extruded boss base for a height of 3 millimeter above the surface. We then add a boss at the back end. Select the back face, make this so let's move out of the current sketch. Select the back face, make this a sketching plane, going normal to it. Use the line as the sketching entity. Draw a vertical line and then an arc. Let's go back and move forward. Let's make it using a 3-point arc. Use line again to add a vertical line and then a horizontal line to make the closed contour. Use smart dimension and assign a height of 70 from the bottom of the base to the center of the arc above. Add relations of tangency at the points of intersection between the lines and the arcs. Add a radius to the arc as 42. Add a center line passing through the center of the arc and fully define it by assigning a symmetry relation with the base. You can pick up the two extreme end lines and the center line, assign a symmetry relation. Okay, just select the line here and assign it a vertical relation to fully define it. Extrude this by go to features, extrude boss, and add a distance of 70. Reverse the direction. Drill a Counterbore from the other end using features toolbar. You have hole wizard. Select the hole type as Counterbore, standard as anti-metric, and then check the box show custom sizing. If it's unchecked, make it checked, and then assign the drill diameter as 45. The drill diameter is 22, and then you have the Counterbore diameter as 45, and the depth of the Counterbore as 50. End condition, we make it up to next, so it passes through the boss and opens up over here on the other end and stops. Position, select the back face and then drop the center on the face. Define this by selecting the center position of the Counterbore and the arc above and assigning a relation of concentricity between the two. Accept this and accept the hole wizard option in the hole wizard property manager. That creates the Counterbore hole. The next step is to drill 4 holes on the base, and you can do that by drilling one single hole and then adding a pattern feature to copy it across rows and columns. It can also be done by making sketches for the circles and extrude cut. That's another way, but let's have a look at linear pattern to copy it across rows and columns. We select the top face of the boss, make that a sketching plane, add a circle here which is having a diameter of 21. And it's concentric with the arc. Select the two arcs, make them concentric to each other. You have a fully defined sketch, extruded cut and cut through. This hole needs to be patterned across the row here and the column, so we go to features toolbar. You have linear pattern. There are two directions to be specified in the property manager. Select direction 1 and pick up any edge which moves in the direction 1. So you have an edge here which moves along the negative x direction or x direction. This is in the positive x direction. Would like to have another one on the other side here, so you may reverse the direction next to edge 1. You get the arrow direction here pointing towards the left side. You have distance between the two, the number of instances. This is 2 of the holes that you require, and they are to be spaced at a distance of 216 from each other. Second direction, pick up any edge along z direction. So we pick up the one that's on the top here. It's moving in the correct direction, so no need to reverse the direction. And the spacing between the two as 72. Number of units or the instances as 2 again. Scroll down to add the features and faces. You may directly add it from the interactive screen by picking up the surface here inside the hole. This is one way, or you may add it from the design tree. Open up the design tree and then select the feature cut extrude 3, which is the last one in a design tree. Accept this. The next is to drill a hole coming in from the top of the cylindrical boss here, opening up into the Counterbore hole, and it's a tapped hole which is to be drilled in. So we select the back face here, get a sketch plane and drop a point to locate the axis for the center of the hole that is to come up. You can go normal to the surface and pick up the topmost point on top of the boss here. This can be done by using the snap. Save and exit. This is a fully defined sketch on the topmost point on the cylindrical boss there. Going over features and adding a new reference plane on the top. Go to reference geometry plane. The first reference, the plane passes through the point here, so select the point, make it coincident. The second reference, pick up the surface of the cylinder and assign a tangent relation to this plane and the surface. Accept this. This is added as a plane 3 in the feature manager design tree. Select features and then add a hole using hole wizard. The hole type as straight tap, standard as asymmetric, and then you have the size as M12 by 1.75. So we have got three sizes here, M12 by 1.25, 1.5, 1.75. In the drawing it's given as M12. So if you are not provided with any pitch value, you may pick up the coarsest pitch, which is 1.75 in here, as the thread pitch. The end condition for, let's uncheck the box for show custom sizing, as we already have a standard size available. We have end condition for this as up to next. The hole is to drill on the top and then open up into the counterbore. Going over positions tab and then select the surface here. Okay, we have picked up the new reference plane. So we'll try to hide the plane here and then select somewhere else on the screen so that you move out of the selection. Click on hole wizard, hole type as straight tap, standard and symmetric, size as M12 by 1.75, end condition up to next, positions tab, and then select the surface of the cylinder to drill the hole. So before we move out, let us try to define the position of the center here. We can go to the top view, add a center line passing through the previously sketched point. We have it here. Add a center line, make a relation of coincident between the center of the hole and the axis. Assign a distance between the center to the back end here by picking up the edge or the point. (32mm), and this fully defines the center position for the hole. Accept this. You may change the display style by going over options and the standard toolbar, document properties, detailing, and check the box shaded cosmetic thread. So we get a display of the thread inside there. Next step is to add the two threaded holes on the slot body. So we go over hole wizard and the features toolbar. Select the hole type as straight tap, standard and symmetric, size as M20. We have got M20 by 1.5, M20 by 2, and 2.5. We select the coarse pitch, which is 2.5, end condition up to next position, and select the face on the slot body. This is one instance, this is another one, so there are two of these. Let's go normal to this and define the center positions. You have center to center distance as 90 and a distance of 45 from the top edge. These two are at the same distance, so we pick up the two and assign a horizontal relation between the two to have a distance of 45 from the top edge. It is also symmetric about the center line, so the 90 here is 45 on either side, so we assign a relation of symmetry between the newly sketched center line and the ends of the slot body, and then another symmetry relation between the centers of the tapped holes and the center line as symmetry. This fully defines the center position for the two holes. Accept this. The sketch at the back end here for the point can be hidden. Right click on the sketch number 12 and say hide. Further, add fillets to the sharp edges here by using features, fillet. Pick up the edge that's over here and with the fillet type as constant size and assign a radius of 6 millimeter. We can also add in the other edge here. The edge at the back of the slot body, the one that you have here, connecting the two. And accept this. And another one at the bottom of the boss for the counterbore. So you fillet under features toolbar and pick up the bottom edge here. With the same radius of 6 millimeter. Can change the display to shaded and add a color to the part here. Select the part 2, so whatever file name you assign, select the name of the part in the design tree, right click and under appearance select a color from the color palette. Accept this. Also add the fillets on the sharp edge here at the bottom on these two ends. You may add it in the previous fillet, or you may by clicking on edit feature and assigning these edges to that fillet feature. This completes your module number 11.